Let us apply substitution method to evaluate a couple of integrals. In this case, you should always get the integral to be of the type integral of f of u times derivative of u. So it must be of the type f of u times derivative of u. So we will do three number of integrals, integral of 1 by 1 plus x times 1 by root x dx, and so on. Let's start with the first one. Integral of 1 by 1 plus x times 1 by root x dx. You see that if I let u equal to root x, then I can differentiate both sides with respect to x. So let us differentiate both sides with respect to x. So d dx of u equal to d dx of root x. But we know that d dx of root x is d dx of x to the power half. That's equal to half times x to the power half minus 1. We simply use the formula d dx of x to the power n equal to n times x to the power n minus 1. So that's equal to half times x to the power minus half, or that's equal to 1 by 2 root x. So du dx equal to 1 by 2 root x. This can be written as 1 by root x dx is exactly equal to 2 du. So we got expression 1 by 1 plus root x whole thing square times 1 by root x dx. So if I take u equal to root x, then u dash is exactly this expression with some constant change, and we can write this expression as f of u. Let's do it. So let's write I equal to, let I equal to this integral, and so I equal to integral of 1 by 1 plus since u equal to root x, we can say that x equal to u square. So 1 by 1 plus u square. So we got everything in term of u, and then 1 by root x dx. 1 by root x dx can simply be written as 2 du. 2 du. Now can we integrate it? Of course yes. It is standard integral. Integral of 1 by a square plus x square dx is simply 1 by a tan inverse of, once again, integral of 1 by x square plus a square dx is 1 by a tan inverse of x by a. Let's apply that. So 2, that's constant, we took it out. Integral of 1 by 1 square plus u square du is 1 by 1 tan inverse of u by 1. Of course, plus some constant of integration. That's equal to 2 times tan inverse of, but we don't have u in the equation. We got u equal to root x. So instead of u, we will write root x, and we are done. So tan inverse of root x plus some constant. So first one we're done. So first one we did it, and we got it equal to 2 times tan inverse of root x plus some constant of integration. What about the second one, integral of x square by 1 minus x to the power 6 dx? Let's do it. So once again we write I equal to this integral which we want to evaluate. Somehow we should be able to write 1 by some, or rather a function of u and then du. So what we do is we take u equal to x cube. Let u equal to x cube, differentiating both sides with respect to x. So we are differentiating both sides with respect to x. So d dx of u equal to d dx of x cube. Once again we know that d dx of x to the power n equal to n times x to the power n minus 1. So d dx of x cube is 3 times x to the power 3 minus 1, that's 3x squared. So we can write du equal to 3x squared dx, or we can write 1/3 of du, once again 1/3 of du equal to x squared dx. And so I equal to integration of x squared dx can simply be written as 1/3 of du, x squared dx can simply be written as 1/3 of du. What about other expression? 1 by 1 minus x to the power 6. But x to the power 6 is x cube whole thing square, and x cube is just u, so u is square. 1 by 1 minus u is square. Can we integrate it? Yes, it is standard expression. Integral of 1 by 1 square minus u square, 1/3, that's a constant, du as it is. Now we know the formula for this. Integral of 1 by a square minus x square dx is log with base u log of u plus 1 by u minus 1 plus some constant of integration. Once again we got u equal to x cube, so we write it. So this is equal to 1/3 of log of x cube plus 1 by x cube minus 1 plus some constant of integration. So second integral turns out to be 1/3 of log of x cube plus 1 by x cube minus 1 plus some constant of integration. What about the last ones? Integral of sine of 2 tan inverse of x divided by 1 plus x squared dx. Let's do it. So once again we let u equal to tan inverse of x. You see that derivative of tan inverse of x is 1 by 1 plus x squared, so we can do integration by substitution. So differentiating both sides with respect to x. So we got u equal to tan inverse of x. So d dx of u equal to d dx of tan inverse of x, and that's equal to 1 by 1 plus x square. So we can write du equal to 1 by 1 plus x square dx. Once again we assume this integral to be equal to I. Let I equal to this integral, and so we can say that I equal to integral of sine of 2 times, you got u equal to tan inverse of x, so 2u. Okay, get much simpler expression. And what about 1 by 1 plus x squared dx? That's just du. Now we know that integral of sine x dx is minus cos x, so minus cos of 2u. Of course, since we got 2u, we should divide by 2 as well, plus some constant of integration. But once again, we are starting with u equal to tan inverse of x, so we'll write tan inverse of x instead of u. So minus cos of 2 of tan inverse of x by 2 plus some constant of integration.